Hey guys, it's Solbyte, and today we're going to be going over queues. So in my last video, I went over stacks, and queues are very similar to a stack in the way that they have similar functions, and they work kind of similar, except for queues have kind of the opposite um, implementation as far as how the data structure actually works. So what exactly is a queue? A queue is a type of data structure that uses the FIFO technique in order to in order to store elements. So the stack, as I went over in my last video, uses the LIFO technique, which is last in, first out, but queues use the FIFO, which is first in, first out. So if you guys remember from the stacks, basically what that means is that the last element that you store in a stack will be removed first, right? But here for a queue, the very first thing that you store in a queue will be the first thing to leave that queue. All right, and common examples, for instance, are just like a normal queue, a normal line in real life, right? Like whenever you stand in line, obviously the person who was there before all of the previous people gets to go, before those people. So just think of it like a line, like an actual queue. It's in the name, so it shouldn't be too difficult to kind of remember how it works compared to a stack. So, and one other example is queues, like when you would really need to use it in programming. And I mean, the best example of when you would want to is when you want things to happen in the order that they were called. Like, so if someone wanted to do multiple different tasks, and you wanted to make sure that all of those tasks would be done, then the best way to do that is to put them through a queue, so that way whenever the first task that they want to be done finishes, then the next one after that, the one that was added right after the first one, would be done next, and vice versa. So if you have Apple Music or Spotify, then you can think of, whenever you queue up a song, right? Like whenever you want that song to play next, and you can add multiple different songs to that queue. So yeah, so enough yapping. Let's go ahead and actually implement this. So in my last video, we did include stack, and here is no different. We're going to do include queue from the standard template library. All right, and then down here, let's actually create it. Once again, very similar syntax. We're going to do queue and then define the data type of what we want to be stored in the queue. And then I'm just going to name it my queue. I'm actually going to just name it my, like the actual letter Q. It's kind of easier to remember. So there we go. All right, so now we have a queue. So the main functions of a queue are very similar to the stack, except we don't have top. Instead, we have two other functions called front and back. So we can reference the element that is at the very front of the queue, and we can reference the element that was that's at the very back of the queue. All right, so technically, instead of 5 functions like we had kind of for our last video, the main functions, the main functions for the queue are going to be like six of them. So we still have push, pop, size, and empty, but instead of top, we're going to be using front and back. So let's actually go ahead and kind of show you guys how we're going to do this. So just like with stacks, we're going to do push, and then we're just going to add what we want to actually push into the queue. And let's do a couple of these guys here. We'll just do 1, 2, 3, pretty simple. All right. So now we have 3 elements in the queue. And let's say we want to reference the size of this queue. So we can do cout my queue dot size. All right, and do a little indel there. And just to kind of, get multiple different things, let's actually get what is at the very front of the queue. So what would leave first if we ended up using the pop method? So let's kind of see what returns if we did that. So going to compile that and run it. So the size is 3, and the element at the very front of the queue is 1. And as you can see, that was the very first element that we actually added to the queue. And if this was a stack, then 3 would be the first one to be removed if we use the pop method. But obviously here with a queue, it's just reverse logic in that sense. So yeah, and then what's also really cool is you can actually see what's at the very back of the queue. So if we go ahead and recompile this and rerun it, we can see the number 3. And we can see here that the number 3 is at the very back of the queue. So that's pretty cool, pretty neat. Nice to a nice little tool to use there. And then so now let's see what changes if we decide to use the pop function. So we're just going to pop really quick and see what will be. Let's go ahead and get rid of this size line here. And let's see what will be at the front after we use the pop function. So let's go ahead and once again recompile and rerun, and we get 2, right? Because 1 was popped, and the very next thing after 1 is the number 2. That was the one that was added right after the first one, right? And before any of the other elements. So perfect. All right, and then for the last example, I'm just going to kind of show you guys us basically traversing, or kind of iterating over the queue, kind of in a similar way to my last video where we kind of traversed through a stack. So we're going to do a very similar methodology here. We're just going to do queue int, and let's just do a lowercase q for that one. All right, so this will be the parameter. We just need some kind of queue. All right, and we're going to use the same logic basically. We're going to check if the queue is empty, right? So as long as the queue is not empty, then this will run. All right, so we still have the empty function. We can still use that here to kind of check if the size is 0. And if it is, then this while loop will end. So let's go ahead and see out what will be at the very front of the queue. Do a little endl here. All right, and then similar to the last video where we went over the stack, I'm going to now pop the front element, and then it will go over the next iteration and the next one until the queue is actually empty. All right, so let's go ahead and actually print this now and see how well this works. And remember, since this is basically passing by value, or it is passing by value, we are instead doing all of this, all of these changes to a copy of the actual queue. So obviously nothing will be affected here outside of it. So, all right, so let's go ahead and bring up the terminal again and recompile and rerun. All right, and oh, sorry, I popped before I did the print function. I was like, why do we get 2? Okay. All right, so now obviously we get 1, 2, and 3. Perfect. All right, and that's really about it. Queues and stacks are very similar. They're very easy. They're very simple in C++, with using the queue and the stack standard template library. And in my next video, I think I'm going to go over hash tables. And those are a little bit, they have a little bit more complexity compared to these guys. So just be aware of that. But queues and stacks are incredibly useful for so many different situations. So it's really good to know about these very basic implementations of data structures. So yeah, and if you guys have any questions, please let me know in the comments. I'm always, of course, going to leave some references in the description if you guys want to look a little bit more into queues. And yeah, with that being said, thank you for watching.